Thank you everyone. Now the relation between time period and frequency. First of all, what is time period? Time period is the time taken to complete one vibration. This is known as the time period. That means time taken for each vibration. So in the equation form it will be time divided by number of vibration. Now frequency. What is frequency? Number of vibration produced in 1 second or in unit time. So number of vibration in unit time, that is the frequency. By equation it will be frequency is equal to number of vibration divided by time. If you multiply time period and frequency, then what you get? Time period into frequency is equal to, time period is equal to this is, that means time divided by number of vibration, time divided by number of vibration into frequency. It is the number of vibration divided by time. Now here time and time will be cancelled. Number of vibration will be cancelled. So what will be? It is 1. So time period into frequency is equal to 1. If you side change frequency, then it will be divided. So the time period is equal to 1 by frequency. So it is the relation between time period and frequency. Or in other way, the frequency is equal to 1 by time period. This is another relation. So there are three relations: time period into frequency is equal to 1, or time period is equal to 1 by frequency, or frequency is equal to 1 by time period. Now the relation among frequency, wavelength and speed of the wave or velocity of the wave. Now first of all, what is wavelength? Wavelength is equal to, or wavelength is the distance travelled by the wave when it completes one vibration. That means distance travelled in each vibration is known as wavelength. By formula it will be wavelength is equal to distance divided by number of vibration. Frequency. What is frequency? Frequency is number of vibration in unit time. That means number of vibration completed in unit time, that means in 1 second. By formula it will be frequency is equal to number of vibration divided by time. Now again multiply wavelength and frequency. Wavelength is lambda, frequency is n. So n into lambda is equal to, n is equal to frequency, that means number of vibration by time, into lambda, that means wavelength, distance divided by number of vibration. Here the number of vibration and number of vibration will be cancelled. So what you get? You get distance by time. This is equal to n lambda. What you know about distance by time? Distance by time means distance covered in unit time. Distance covered in unit time means it is speed. So it is the speed of sound. So what you get? Speed of sound is equal to n into lambda. N means frequency, lambda means wavelength. So speed of the sound is equal to frequency into wavelength. So this is the relation between the speed, frequency and wavelength. Now if when you use this formula, here the time period equal to time period is equal to time by number of vibration, or frequency is equal to number of vibration by time, or speed equal to frequency into wavelength, or anything. When you use that time, must you have to convert the time in second. Now take some examples. or numericals, not examples, the numericals. Find frequency and time period when a particle completes 12,000 three zeros vibrations in 1 minute. Time is 1 minute. Next question is, does it produce audible sound? Now you have to collect what's are given. Here the time is given 1 minute. It is given in minute, so you have to convert it in second. We know 1 minute is equal to 60 seconds. Now number of vibrations is given. What is the number of vibrations? Number of vibrations is equal to 12,000 vibrations. Now what is the asked? First of all, it is the frequency and time period. First you find out the time period. The formula for time period already we know, the time divided by number of vibration. Here the time is given 60, number of vibration is given 12,000. Now cancel this 6, it will be 12, it is the 200. So 1 by 200 time period is the unit is second. Now the frequency. What is the frequency? Frequency is equal to number of vibration divided by time. Number of vibration, here the number of vibration is 12,000. Time is 60 seconds. Put it. Now go for cancellation, and again it is 200. Here the add numerator is 200, so it is a 200. The frequency, it is hertz. Unit is hertz, so the frequency is 200 hertz. You can find out the frequency by another formula. We know that the frequency n is equal to 1 by time period. Already you get the time period, then put the time period here, and then again you from here you get also the frequency. You can use this formula also. Now the final question was, does it produce audible sound? The produced sound has frequency 200 hertz. Since it is the 200 hertz, this frequency in between the 20 hertz and 20,000 hertz. Since it is in between 20 hertz and 20,000 hertz, so the produced sound is audible. Now the second numerical. A tuning fork has frequency 256 hertz. Sound produced with it travels 20 meter when the fork makes 16 vibration. That means for 16 vibration the produced wave travels 20 meter. Now find the wavelength and velocity of the sound produced by the fork. Now what's are given? Number of vibration, it is 16 vibration. Distance travel in that period of time, it travels 20 meter distance. Now it is asked to find out the wavelength. Wavelength. What is the formula for wavelength? Wavelength is the distance travel divided by number of vibration. Here the distance, it is given 20 meter and number of vibration is 16. Go for cancellation. 4 5 is 20, 4 4 is 16. That means it is 5 by 4. Since it is a 5 by 4, convert it into decimal and you get it is the 1.25. Wavelength, the unit is meter. So the wavelength of the produced sound is 1.25 meter. Again, what's are also given is the frequency of the tuning fork is given 256 hertz. Frequency is 256 hertz. Now the produced velocity of the produced sound is equal to, we know the formula, the velocity or speed of the sound is equal to frequency into wavelength. Here the wavelength is given 256 hertz and the wavelength already we find out it is 1.25 meter. When you multiply, you get 320 and the speed or velocity of the sound, the unit is meter per second, because it is done in SI system. So it is the way how we find out the velocity. Now the third example or third numerical. It is the frequency and velocity of a wave is 20 kilohertz and 320 meter per second. What the frequency is 20 kilohertz and velocity is 320 meter per second, and asked to find out time period and wavelength. Now the velocity, it is the 320 meter per second. Frequency, it is given 20 kilohertz, but you have to convert this kilohertz into hertz. To convert kilohertz into hertz, you have to multiply by 1000. So it will be 20 into 1000, that means 20,000 hertz. It is the frequency. First of all, time period. The formula for time period is 1 by frequency. Frequency is given 20,000, so 1 by 20,000. After division, what you get? You get 0.00005. That means after decimal there is a 4 zeros and then 5. Or you can write down it is into 5 into 10 to the power minus 5 second. You can write down your answer in that form also. Now you have to find out the wavelength. To find out the wavelength, you use this formula: velocity or speed of the sound is equal to wavelength into frequency. Already we know this formula. Here the velocity, it is given 320 is equal to, it is asked wavelength into frequency, it is at 20,000. Now subtract 20,000 and you get wavelength. So wavelength is equal to 320 divided by 20,000. So you go for cancellation, and then after cancellation the answer will be 0.016 meter. How you this is a cancel, it is the 1000 and it is the 16. If you divide 16 divided by 1000, then you get must be 0.016 meter, and it is the wavelength. Now the fourth. A body vibrating with a particular frequency generates waves of the wavelength is 0.2 meter in the medium A, where velocity of the wave is 160 meter per second. Calculate the wavelength of this wave. It will generate the another medium B in which its velocity is 240 meter per second. That means same vibrating object when vibrate in A, then its wavelength is 0.2 meter, and when this particle vibrates in medium B, then find out what will be its wavelength. In the medium A, the velocity of sound is or wave is 160 meter per second. In medium B, this velocity is 240 meter per second, and it is the your homework. To solve this numerical, there is a hint. The velocity and wavelength of the wave changes when the wave travels from one medium to another medium, but frequency does not change. That means when a wave travels from one medium to another medium, its velocity and wavelength both are changed, but frequency of that wave remains unchanged. These tricks will be applicable to solve the problem number 4, and it is your homework. Thank you.